This video is on the individual gas law called Gay-Lussac's law. So this gas law deals with the variables of pressure and temperature. So just like in Charles' law, temperature needs to be in Kelvin, and the pressure units need to match. So meaning they both need to be torr, they both need to be millimeters mercury, etc. So you may have to do a conversion of one or the other in that case. This means the constants are moles and volume. So they aren't changing. So our equation in this case is pressure divided by temperature will equal that constant K. So the equation way looks like this, with pressure divided by volume, or sorry, pressure divided by temperature will equal pressure divided by temperature. So multiplying was inverse in Boyle's law. In Charles' law, the two variables that were being dealt with were being divided, so that was direct. And these are also being divided. So this is also direct. So as pressure increases, temperature decreases. Or sorry, direct. Temperature increases. So let's write that nice and big. This is also direct. So they are the same. As one goes up, the other goes down, and vice versa. All right, so our problem. All right, we have a sample of gas occupies 10 liters, so it's a volume, at 114 torr, so we've got a pressure, and a temperature of 27 degrees Celsius. All right, calculate the pressure, so that's what we're solving for. The temperature changes to 127 degrees Celsius, while the volume remains constant, so we can cancel the volume. I'm just going to cross it out because it's not changing. So our variables are pressure and temperature, so I'm going to make my little chart. All right, so my initial pressure is 114 torr. And the temperature at that point is 27 degrees Celsius. So remember, we have to change this to Kelvin. So plus 273 gives us 300 Kelvin. And we're going to keep that 3 sig dig. So I'm going to put the decimal there. And then calculate the pressure. So that's our unknown. If the temperature changes to 127. So again, plus 273, that gives me 400 Kelvin. All right, so I've got 114 torr that I need to use temperature as my conversion factor for. All right, so my temperature goes up, which means my pressure is going to go up in a direct relationship. So I'm going to put my higher value on top, so 400 Kelvin divided by my smaller 300 Kelvin. Kelvin will divide out, which gives me an answer of 152 torr. That's the unit I have left.